in to Parallax and all software and stuff. I thought he could, and he didn't have one, so now he's going to have one.
Roy's very deserving.
Yes, indeed.
Okay, why don't we start the P2 live forum? We have the team from TeamOz is up and going, so let's get them while they're sharp.
Ken, sorry to interrupt. I don't know if you saw Lachlan just made a note that he had to reboot very quickly.
Okay. All right, so well, we could talk about whatever. I don't have any notes for today, any housekeeping stuff. Do we have any new objects that were posted?
I haven't sent them for posting yet because you don't have those on the web yet, but I've got the Click 4 to 20 transmitter and receiver boards going, and the Click relay board, which is almost no code because it's just a couple of IOs, and the RS-45, and also the real-time clock. The real-time clock is somewhat extensive. It does a lot of nice stuff. So I have those. So when the clicks are up, I'll send you those for posting.
Yeah, it's fine. It's the same thing applies. We can wait till posting until you're done in almost November.
Well, I found that, you know, I was going through and doing little touch-ups to my core. I have a Click template with some core objects for it that are, you know, bare bones I2C, bare bones serial, bare bones SPI, and bare bones analog in and out. And those are part of the core. And I found as I was doing other things, I was making little tweaks to them.
Yeah, give you some time to work with them.
I realized, Ken, that I forgot to email you which which of the few clickboards I wanted. I'll try to get to that over the next couple of days.
Yeah, that'd be great. Just tell me what you'd like.
And an adapter.
Yep.
I had a question about the P2 Edge based on this thread controversy about it with the HyperRAM. My understanding that there was going to be two, one with HyperRAM and one without. Is that true?
That's what we're thinking, yeah. And then we have the USB dilemma to throw in there as well, whether or not we put USB on it. But that is, we'll make one with the RAM.
Yeah, it was just weird to me that people were complaining about we're making an Edge with the RAM on it because there's going to be one without. So if you don't need it, just buy the one without, right?
Yeah, it seemed like
it would be a few dollars cheaper, right?
I think so. Yeah. We still haven't priced the darn thing.
Yeah. I'm a fan of just having the USB be on the board that you plug the Edge into.
You're okay with that?
I'm totally fine with that, especially if there's 4 pads on the back of the Edge that you can solder a thing on for a prop plug. I don't think it matters to have USB directly on it. In fact, I'd rather it wasn't.
Yeah, I'm with Roy on that because I don't need the HyperRAM. What you showed last week, I thought that was already going into production. That's perfect for me. And one of my clients is already, you know, I think I said this last week. He does specialty stuff, and it's all through hole. And now with using that Edge and a socket, he can add the P2 to some of the specialty projects we do, like target controllers and things like that.
So is it still a plan to make a board with the connector on it that has the pin sticking down, like you showed a picture of a few weeks ago? There was like a little tiny board that was just a USB plug and pins sticking down that could go into a breadboard, and the Edge connector on top that you would plug the Edge into.
There is. So there are 2 such boards, and one of them has headers for the click boards and the P2 accessories, and one's more like a breadboard adapter. Neither have USB on them. They're just connectors and through-hole PCBs.
Okay, and then you just plug in your prop plug or whatever
to the P2 Edge. Yeah.
Yeah. And then you're going to make the signature John McFarlane PDB Lite board.
Meaning the P2 Edge breakout board, the one we showed last week.
Yeah, the one that looks like to me the development board light. It has the
Yep.
breadboard in the middle and the connectors around the edge and the servo.
Yeah. So the first things you're going to see are we're pressing to get all these wrapped up here in October. So we have them when we switch over our new website in early November, and those will be the two products and the other two little through-hole adapters too.
Excellent.
Yep.
Excellent.
John's board looks a whole lot like Stampworks.
Yeah,
It
it does.
Yeah, the straight drop through one where it's just the edge connector going down to a breadboard, I can plug that into my existing PPDB into the breadboard on that, and then use all the buttons and LEDs and whatnot around the edge from that, and just ignore the P1 on there, or use them both.
I was actually thinking of making a P2 edge adapter that would plug into the 40-pin dip socket on the PDB.
Yeah, that's all good.
Yeah, that would you wouldn't have as many pins, of course. You'd only have 32, but it would still be useful.
Yeah, and you could have a row of pins on that little daughter board for the extra 32 IOs.
Yeah.
You don't have to populate. They could just be little holes there that people can populate as they see fit.
Well, Lachlan is here from the reboot. He's survived.
It's Lachlan rebooted.
Yeah.
Lachlan do.
All right. Do you want to run through, have you already run through your stuff, Ken, or?
Yeah, I didn't have anything today.
Oh, okay. No worries. All right. So we get into it. All right. What I want to talk today about, as you know, Brian and I have presented previously on MicroPython software. So the MicroPython software we're using here regularly, Brian's using it just about every day, and he's doing a lot of work with a self-hosted system, which means the files and the editor are actually hosted on the P2 itself in flash memory. And that's quite a convenient and trouble-free system. He reboots less frequently than I do, I believe. So yeah, so there we go. But what we want to talk today about is this hardware encapsulation of what we've actually been demonstrating to certainly a lot of MicroPython people. And so this is a dip-based or 0.1-inch based board, which we're finding we can do a lot of things with. Plus, we've added where the red LED is. That's an encoder, like a rotary encoder that you can buy from Bourne's, and it has a LED, a switch, and obviously the A and B encoder outputs. And that's useful because it represents digital input, digital output, a kind of an analog input on the rotary side, and also you can use the PWM digital output or analog output to drive the LED intensity. And so basically in that one device, you've got every form of analog and digital I/O testable and demonstratable. And then on the end of this module, and I realise you can't see it, but we'll zoom in and get some photos and things in a moment. We've got VGA, because most of the time we have a VGA monitor and also a USB keyboard plugged in. So
hey,
that
Lachlan, can you share your video?
yeah.
We're just seeing Ken.
Ah, how is that possible? How do we do that, Ken?
Okay, so click on his video and then click
Into first window.
Pin Video.
Got it. Okay, this one. Sorry, that
No,
should be...
Jim would do that, not you, Lachlan.
Ah, because I've
So
just been...
tell me now, I don't know the difference between pin and spotlight, but did this make him full size?
That's good. Yeah.
Okay.
Yeah.
Hopefully the
Yeah,
recording keeps it that way.
Okay. Great.
Okay, so what we're talking about today is like a hardware combination which we're going to use to showcase MicroPython. It fits in with the kind of things with the microbus boards, which are plentiful. There's about 700 or 800 of these boards now in existence. And I know Johnny Mack has been writing some of the code to exercise these boards. So what I'll do now, I'll see if I can share a bigger picture of this.
So is there a P2 on there somewhere in what you were just holding?
This is a prototype like this board. The P2 basically sits on the underside, a little bit like the flip module works.
Okay.
Let me just work out how to share the screen here, and then we'll share the screen. Okay, can you guys see that enlarged photo?
Yep.
Okay, so what we've developed at work, can you see my mouse cursor as well?
I can, yes.
Yep. So we've developed at work a small board for our own purposes, which has the P2 on the top of the board mounted in the middle here, and it has connectors on the end, and it also plugs into existing P1 DIP40 sockets because our traditional hardware has got those sockets underneath. So that's where this design has evolved from. What we've done is kind of converted that to a rigid 0.1 inch grid to enable all the signals used in this design to go either up or down. And so that means you've got a lot of flexibility in terms of how you configure the board. And you can obviously work out ways to stack it, but natively it means it can also take 2 microbus devices straight up into the top socket to enable rapid prototyping and development. So in this particular case, we're using it in the DIP40 configuration, and that means there are 2 single inline 20-pin headers going down to the breadboard, and there are also some female headers going up to the microbus sockets. And you can see these are the official microbus manufacturer and sell these official sockets, which are nice. They've got the labels alongside each pin. And so the way this board works, this is P0 in this corner here. And following the DIP40 footprint, you're going up to P15 along this edge on the inner side, the one that's plugged into the breadboard. And then on the far side, it starts from P16 and comes back to P31 in the corner here. So that's the inner circle of I/O, which is compatible with existing DIP40 products. On the outer side, you've got the higher numbered I/O. So P32 starts here, and that does P32 up to P43 for this microbus socket, giving you 12 pins of I/O. And so we're using 5 pins for VGA, 2 pins for the USB socket. We also have some servo connection headers here, so you can actually see something move. And we have the encoder with its LED button and A and B encoder signals. They're consuming all those 12 pins. And on this module down here, this is an FTDI plug-in board. It uses the high-speed FT2232H, and multiple signals are connected through as described in the screen printing there. So this is basically what we believe is a nice encapsulated system for demonstrating the MicroPython smarts and the smart pins, you know, which can capture things like encoder count and then also drive the servos autonomously. And yeah, so that's what we're planning for the DIP40 module. So I'll just pause there and see if there's questions regarding that setup.
So the first 32 pins that go down into the breadboard are all free to use for whatever you want?
Correct.
And then each of the click connectors uses 12 each?
Correct. So P32
so the other,
P55. Yep.
So the upper bank of pins, are they just not connected, or?
They're available on the outer, like in between, there's like 4 pins here and 4 pins up there for connecting them out. But in the DIP40 thing where you're plugging into an existing P1 socket, they are kind of self-contained. So the flash memory, which is internal to this system, and we're also going to put some pads to put we're going to try to put a micro SD card vertically in here on a vertical circuit board. So you will be able to sort of swap a micro SD card in the middle here. That's a sort of a longer term plan. Initially, we're not going to worry about that, but that would have access to the SD card pins.
Oh, cool. So there is a flash chip on there that will
Yeah,
boot
sorry, the flash
P2 and
chip is
everything.
underneath, along with the
Yeah.
P2, the crystal, the voltage regulators and capacitors and things like that, configuration
Very,
switches.
very cool.
Yeah, so it's sort of similar to what's on the P2 Edge, but on the underside of the board. Yeah, that's correct.
And then is it possible to use this FTDI board as the communication to the P2 on what, 62 and 63?
We're going to put some pads there to jumper those pins across. I'm not convinced we're necessarily going to go that way, because in some ways it's useful having a separate, oh, sorry, I should mention there is actually a prop plug connection just sitting underneath here. And so you can actually slide a traditional prop plug in for programming the P2 side of it.
Excellent. That answers the question. So the FTDI is really just a separate serial channel for you to communicate on.
Yeah, correct. Yes. Yep. Yep. In fact, it's 2 serial channels. And so...
oh, okay. Even cooler.
Yep. We're likely, because it sticks out so far, Roy, we'll probably at some point compact all this down to have one, like a more compact version at this end to kind of balance it up a bit. And also use a cheaper, like an FT231, or even look at, Peter Jakacki and JMG's Scilabs chip, UB3 or whatever, might be a possibility there. The nice thing is we can change what USB thing is plugged in, what device is plugged in here pretty easily.
Well, it's a click port, so it doesn't even need to be USB. It could be any click port, I assume.
Yeah.
Interestingly, have the appropriate software.
Yeah, they don't have many UART to USB click adapters. There's kind of, for so many boards, there's actually a few holes in there, which, coming from a Propeller world, it looks like they need a couple of, just things like an FT232 and 231 and CP2102. These kind of UART boards are kind of missing from the range. Anyway, that problem's pretty easily fixed. So obviously, we're going to develop some custom microbus boards, and I'll talk about these later. But starting with this MicroPython sampler board we've got here. But yeah, I can envisage, the boards don't need to be as complicated as the FT22321, nor as expensive. But it's just a pity they don't exist off the shelf right now. So yeah. All right, any other questions on this format? There's probably some photos here too, that's showing sort of an end-on shot where where you can see the pins going down to the board here, and the pin and the female sockets going up to the microbus on the outer edge. And you can also see this is actually on the output side. So this is actually a cascading prop plug, driven by pins P56 and P57. And also there's a reset signal coincidental with the reset signal from the microbus, which I think is P51 here. And so what that means is you can jumper these pins onto the next one in line. If you run out of IO pins on one module, you can create a longer version and have one P2 program up the next one. This is a parallax. We've been sort of evaluating different brands of breadboards, but this is the parallax it's a 300 hole breadboard normally. It's missing its power rails in this view, but this is the official parallax board breadboard. That's a little bit closer. These pins on the end, we've used these are like a rectangular pin. Actually, I won't go into the detail on that because we might change back anyway, but the idea was that these would be a bit springy and kind of bend, like if you need to use it at a different angle because you've got a long board above it. So those pins are fairly flexible. Right. So this is the format where we've loaded up exactly the same circuit board, but with dual inline headers. And so we can still use microbus boards plugged in, but we are just using the top surface of the headers. These are a pass-through header, which are commonly used with things like PC104 and the Raspberry Pi. They're a very high quality pass-through connector compared to what you're used to with things like Arduino. They have square pins. They mate really solidly. This particular one has the extra spacer, which is used probably for things like PC 104. They're a super good quality connector. So this has the dual inline. So this is the DIL 80 format with the dual inline, twin dual inline things. It would be more suitable for new designs because it can't easily adapt to the P2 DIP 40 sockets unless you go through and chop out all the outer pins, which is, and because they're square, they're quite sturdy. It's a bit of an effort. So this is the dual inline format. It's more suitable for sort of newer designs. But as I mentioned, it's exactly the same circuit board. It's just soldered. The headers are soldered in a different way. And these microbus modules you can see here, this is the official microbus encoder. They make these in, you know, the 5 different colors, and it doesn't have a LED lit shaft, but it has these LEDs around the outside. It's a pretty cool device. And this is also the microbus for the grid eye IR sensor, which is an array of like 8x8 thermal sensing things. It's like a low res thermal camera, which I'm hoping to do a P2 object for, along with a bit of help from Ozprop probably. So yeah, this is in the sort of what we regard as slightly more professional kind of version incarnation. Yeah, so same thing. There's a flash on the inside. There's prop plug programming pins here at the end. You can't plug it into a breadboard because you're going to short out, you know, the inner and outer pins directly. However, it can be adapted if you need to change it over by cutting off all the pins and adding an extra inner header up here. Yeah.
This would be something where you could design a board that this would plug into.
Yeah, and so it brings out all the I/O pins, and that way you've got, you know, all everything available if you want it down on the baseboard.
These are good.
Yeah, so questions, have we got questions about this format? Okay, so we'll move on.
I have one question. That 8x8 IR sensor, how much does it cost, and do they make those in much higher resolutions?
They make a FLIR lepton. I think Rayman on the forums has had that up and running. So that's a this one I'm trying to remember. I think it's like a Panasonic device, the 8x8. I don't believe they make them in much higher resolution because for a while there, they were like an export restricted item. You know, they're worried about people making some kind of tracking, you know, some kind of pseudo military thing, I guess, but they aren't as restricted anymore. But if you want to go to a high resolution, the FLIR Lepton series, you know, they have a few generations of that, which kind of double in resolution with each series, and you can make a pretty serious thermal camera with those. You know, so
FLIRs are pretty expensive though.
yeah, my recollection on the FLIR plug-in version though is that maybe the actual sensor part is around $200, sort of 150 to 300 US dollars, I believe. But I think the socket can take like the older, smaller, lower res one or the higher res one, you know, depending on your budget, is how I understand it. Probably want to do your own research just to verify that, but I did look at it at one stage because I think the P2 could do a super neat display of something like an 80x60 thermal grid, because you could use a character mode with background colors and basically print the temperature in each cell, but change the background cell color to be like pseudo, to do that kind of false thermal coloring. And so you'd have both the text information and the temperature kind of indicated. And I think that would be kind of an impressive demo. That's something I'd like to try, at least get running with the 8x8. I think the 8x8 version here, they were something like $50 or $60, you know, for that little sensor.
I think it's 80.
Is it 80?
Mm-hmm.
Okay. They have specials. You look out for the
coupons.
20% off, 20 or 30% off. I think they go up to the micro sales. So maybe around is it Black Friday or whatever maybe coming up? Maybe there'll be a good sale. I don't know.
Lachlan, does that thing have, it has some kind of lens built into it, right? Because you can't use normal materials to build lenses.
I think it has, effectively it has it's like an angle sensing kind of system.
Oh, okay.
So it's kind of, it's not so much a lens as kind of
Directional
response.
sensors.
Yeah, because what I found, we've got a little, I think it's a Fluor C3 thermal camera, which we use, and it's not rated for doing close-up work, but it does do close-up work. You can go really close. It's not like it defocuses. The optical side of it defocuses, but the thermal bolometers or the thermal wells, you know, that make up these devices, they seem to just respond to angle, and so you can put it right up close to something and still resolve, you know, detail. Is my experience with them. So yeah.
So you'll produce a couple objects for those?
Yeah, well, I'm looking forward to getting to producing objects. And I'll probably have a chat to Johnny Mack and just see if we can look at some. Oh, I think he's already uploaded the drivers, but just kind of try and do it in the same style and make sure we've got, you know, sort of compatible stuff which looks, you know, like it's similar. So if you're familiar with those objects, those numerous objects which Johnny Mack has worked on, then hopefully we'll keep it in the same kind of style, and you know, for interfacing and making the code sort of readable.
Great. I'm going to get these in stock.
Yeah.
Sales guy here.
Yeah, it's going to be a good demo, just combining the text and graphics kind of at a low, like obviously you're not going to need much memory. And the other thing you should be able to do with these is move them, you know, put them on a servo and kind of do a sweep and assemble a picture, you know. So I can see that would be a useful extension to the fixed device there. Yeah. So that's the dual format one. Now let's see what else we're going to look at. I can show you a couple of things. So the circuit board. Hello, morning. Not in yet. Yeah. Right. So here's the layout as it stands at the moment. You can see there's a flash chip over here on the left. There's the crystal over here on the right with both a surface mount and a traditional HC49 crystal. The P2 is sitting underneath, and you can see the trick used here is to actually pull out. There's 4 pins here which get removed from the DIL header in order to make this thing possible. Otherwise it's it doesn't fit, obviously. You know, people have probably tried this. And there's also this brownout enable pin here is also been removed. I don't think anyone's going to miss that. So yeah, the power comes in just through this single this incoming power pin here. And while this says 3.3 volts, it'll work with 3.3 volts with the regulator we've got in mind. But we'll also have the ability to put in a higher voltage either through this pin or through the 5-volt pins of the microbus sockets, and have that sort of managed on the system. So that's our current layout. We've used a rigid 0.1 inch grid on all the you know, the through-hole pins, and we've got, you can see up here, apart from the prop plug, we have like a 3.3 volt in, and there's likewise a 3.3 volt pin going out, so you can, you know, cascade these modules. You can see here, you know, we're using P56 and P57. Can't see there, but there's a couple of LEDs in here somewhere which are P56 and P57, which I've deleted. This is essentially a 3-layer design. There's a power plane in the middle of these signal routing ones that are currently on screen. What that means is the top surface of this is basically free, and we can look at using that for, you know, whether it's used for labels, or even I'm thinking maybe even like a Goetzel demo kind of thing on the top layer. These things are all kind of possible because it doesn't really need the 4th layer on the 4-layer board. And so we do have some flexibility here, as long as we avoid some of these inner pins and vias. We have a fair bit of room on that top layer where you could do something interesting. if we want to down the track. So let's see now. All right, so going back to the original, the DIP40 one, I don't know if you guys remember the smorgasbord from years ago. The smorgasbord was a collection of open source Propeller 1 designs from people all around the world. We had, I think, about 21, 22 designs on this board. And there's everything. Some of them are DIP40 based. You can see there's the Gadget Gangster Propeller platform here, which is the DIP40 one that Johnny Mac created. And
I've got 4 of those.
You got 4, okay. You've got there's a board in the corner here by Reba or Andy from over in Europe there. This one here, I can't quite remember whose this one was. This is Phil Pilgrim's prop stick up here in the top right, and that's the physical version of that. This was nice because it had a DIP40.
Bill Henning's board, second one lower.
Which one, sorry?
Number, so bottom row, second
that
column.
one, Bill Henning. Yeah.
I think so.
Yeah, it's got like that's like a Wii connector or something, or one of those gaming connectors. Yeah, that's well recognized.
Hanno has
The
one on
nunchuck, the nunchuck add-on.
Yes. Yeah, that's right. So
Hanno's got one on there too.
yeah, Hanno had his Dan Spot board is I think this one here underneath the middle there. This was one of mine used with industrial. This has got like opto isolators and FETs on the inputs and outputs for running with 24 volts DC in an industrial setup. There were quite a few. This is Andrew Williams, I think, did a breakout, DIP40 to QFN converter. Some are Cluso's boards up here. These little tiny ones I think are mostly Cluso's. And this is a Ninja board I did at some point. But anyway, the thing is there's quite a few DIP40 based boards on this, and this is going to be a sort of a little test bed. We'll just see what would be involved. If we're going to put this on an existing design, one of the questions is, okay, well, how much current you're going to need to beef up a little bit the 3.3 volt supply. So in some cases that might be as simple as just putting a switching regulator, so one of these 7805 style or a 7833 style switching regulator into like a socket like this. It looks like pretty straightforward. And we can look at some of the other designs and just see, like looking at the existing designs, what's involved in kind of beefing up the power a bit to drive the P2 at a reasonable frequency, or high frequency, I should say, and just see what's involved. Because I suspect in a lot of cases it might be just a matter of upgrading the regulators, but we'll see. And also put a thermal camera on there and see. The regulator in here is obviously fairly thermally constrained, and so that's a kind of provides a sort of a check for whether this thing really can upgrade P1 based designs, of which there are obviously so many out there. That's out of focus, but that's the guy from Mexico who did that I think it's called Parallel or something like that. He did that breakout board last year for a year or two ago for breadboards. And
I got a couple of those.
Yeah.
Yep, same here.
Yeah, it's a like a kind of neat design, and again, we should be able to just replace that DIP40 with the P2 DIP40 and see how we go, see what's involved.
Was that the Kickstarter one?
Yeah, it was either Kickstarter or crowd supply, or one of those. Yeah.
Okay, yep. So I got one of those. Yeah.
Yeah.
Works good.
Yeah. Oh, there it is. That's in focus. Yeah.
That's better.
That's much better. It's going to delete that while we're here. All right, so flip module. I'm going to also look at this sitting on top because you've got pass-through connectors there. I believe it'll be possible to put the flip module on top. I've just got to check how Obviously, our board has also got to take the same voltage here, and I think the flip works down to around just over 4 volts on this pin, even though it says 5 to 9. And so I just want to check whether, because this will create like a hybrid P1, P2 system. But the other thing it does, it's already got the USB all looked after nicely. So compared to that huge FT2232 board, everyone knows how convenient this thing is to use. You just plug in the USB, micro USB cable, and away you go. And so if you're coming from the P1 world, it might be actually quite convenient to start here and then gradually, combine in what you might need the P2 cogs to do, and kind of build a hybrid system if anyone's interested in doing that. It'd be, not take any more lateral space. It would just take a little bit more vertical space to do that, to achieve that. All right, so that's the P2 DIL and DIP boards. This is a sneak peek of what I'm looking at doing with a breakout board to bring in more microbus sockets beyond the 2 which are included on our board. And so this is breaking out, in effect, the port A or P0 through to 31 into 4 microbus sockets. Obviously, when you do that, you can only have 8 pins per socket. And it's really common in the microbus world they do some cheats. And one of the cheats is that they don't have separate SPI and I2C. They combine the I2C pins in with the SPI. And so what that means is you don't need to have, 12 pins like we're proposing. You can get away with less pins. And what the idea is here is that the last 3 lesser used pins are going to be almost DAC encoded with 3 resistors here onto a single P1 pin. And so you still have access to the interrupt, the PWM, and the analog pin, but they are coded by resistor. And at the other end with the P2, of course, you can have either resistor or a current source, which enables you to decode which signal, is it the interrupt pin or the PWM pin which is signaling me, and resolve, what's going on. And of course, you can use the pin A greater than D mode to set thresholds to know what's going on. This board will be built with both the parallax edge in mind in the middle here and the P2 DIL 80 and DIP 40 board. And all of those will be usable with this board once you get the detail on the edge connector, the pinouts, and which way the I/O goes. Similar kind of thing in that you can cascade in and cascade out to make more of these. And this thing is designed to fit in a Hammond 1551X case, which is what the white outline, that's the inner wall and the outer wall of the Hammond case. And these are the mounting holes for it. Hammond have also released a vented enclosure. So same thing pretty much, but in a nice, like with ventilation. And that's going to be important for some of the P2 designs, just to have that natural ventilation. They still look like a nice case. If you want to look up the part number, it's 1551 V4 is the one for this size board. And they also have like a 1551 V3, which is like half the size. And the V3 one will be suitable for just enclosing just a DIL 80 or DIP 40 board. There's a little bit of stuff going on down the bottom here. So one thing we've realized is with we've got microbus headers in these outermost pads, but we've also realized we can put the footprint for P2 accessory boards just in from those. And we can also put Digilink PMod connectors in. These systems have slightly different pitch. So Parallax use a 1.1 inch pitch. Microbus normally use 1.15, but are perfectly happy with 1.0. And then the other thing we've got back here is like a servo connection system for connecting servos or devices like individually, so 3-pin servos or things like the ping sensor. You can bridge across. One side of this is 3 volts and one side is 5 volts. And so you can just bridge, whichever side you need to set up the voltage on your servo headers per bank, you can do that. There is a question mark. We might put Arduino, these Arduino pins would enable you to put an Arduino shield in. you would have to externally connect down here, like bring across the ground and a 3.3 volt signal if you want to connect on an Arduino Shield. So that's an awful lot of different I/O formats in one footprint, and it's going to be, I think, important for, obviously we're looking to work with the micro bus devices, but there's also people with an extensive collection of PMODs, and those people are often involved in FPGA work. And of course, the P2 is really a dream compared to working with an FPGA, and can tackle some of the same applications which you would normally turn to an FPGA for the deterministic kind of side of things, but without all the headaches and lost hair that you get with FPGA development. So that's the plan for the like a 4 and an 8-way, 4 and a 6-way microbus breakout. That would top most of the microbus, like the higher end development boards. They have 5 microbus sockets, and this would have 6. And so, and unlike a lot of the systems out there which are heavily compromised, so you'll find, like on the 5-pin microbus products, microelectronica development boards, microbus socket 1 and microbus socket 5 are basically in parallel, because they don't have the kind of the pin bandwidth to get separate pins. With the P2, of course, we're going to have separate, like we're really going to be able to open up and just have individual sockets, which are, not encumbered by this like pin sharing thing that they do on a lot of the other development boards. It's also a little bit, microelectronica have I think a clicker 4 board. Universal clicker. It's like a board which has 4 sockets and a USB. It's relatively cheap, but it has a plug-in CPU card at the back. And this would provide a kind of an alternative or something to get up and running quickly with the P2 while using the microbus ecosystem. This thing's actually pretty compact. This is, I think these cases are 80 millimeters square on the outer dimension. So that's 3 inches square. Sorry, any questions regarding that setup there?
A question so much as just that's a pretty awesome array of possible options.
It's all the options we could think of anyway. I didn't mention that we're thinking whether we can get LEDs along this edge just to signal, this is P0 here up to P, and it'll be logical. The other final thing I'll say is you may be able to use this with the P1. I haven't given it a whole lot of thought yet, but obviously this internal socket, this socket here is designed for the P1. And, so perhaps this would be also a leg up for the P1 development if we, because we're going to be writing spin-based drivers for these microbus sockets. There's probably not a whole lot of extra work to actually get them going with the P1 as well. But we'll see once we get into that process. So, yeah, thanks, Roy. I know there's more about that, which I'm kind of forgetting at the moment, but
so clarification on the 40-pin dip setup, the non-IO pins are compatible with like a P1 or flip module? Is that how it's set up? Like you can plug your 40-pin dip in instead of a P1 and it will work as long as there's no dependency on those the XI, XO pins and stuff.
We aren't connecting, like they're not there. We would put them down on this board just so that you can put a physical, thing on here, but they aren't connected through the bus. You'll see they're missing from here.
Right.
So the only pins which are brought in as ground, the reset, and the power in, and so you're kind of constraining everything to go in through those pins. And therefore, because the usage of those 3 doesn't vary, you've always got reset there on the flip and everything else. You've always got power in on this pin here.
Right.
Obviously,
that was what I was asking, and you've answered it fully. So I could plug in. I have a board that takes a flip right now, and I could plug in your 40-pin dip thing with the P2 on it in place of the flip, and it should just work.
Yeah, actually, it's a good point. The flip would actually make a really nice one because we've already got the USB looked after. And so for this, you know, you just cut a hole in the sidewall of the thing, you put your USB cable in and you're up and running. On a DIP 40, like a physical DIP 40 chip, we need to reintroduce these pads and bring the power wiring across, you know, like you do, and probably just a decoupling capacitor and crystal, you know, so that's possible because these pins aren't physically there on the when you put a stacked thing in there, so they're not going to interfere with the dual 80 or the DIP 40, I just have to check what happens with the flip, but I'm pretty sure that things have been looked after and made pretty compatible with the design on that.
Very cool.
Yeah. At worst, it's just going to require like a switch or a jumper or something just to set whether you're plugging in a flip or plugging in a DIP 40 physical chip. The other nice thing about, I mean, this will be just a 2-layer board, so it'd be nice and cheap and entirely kittable, you know, really it's just soldering the connectors that you might need. So if you've got P2 accessories, you're going to want to plug, you know, you're going to want to solder in these connectors here. If you have PMOD things, then you're going to want to solder in these connectors, which are like a right angle thing, and you're probably going to want to run them underneath the board, or, you know, it's probably an either or, you know, you're either going to have digital PMOD because you've come from the FPGA world, or you're gonna parallax, you know, if you're from the parallax ecosystem, you've probably got parallax accessory boards and headers and, you know, pings and laser pings and all these kind of sensors. Obviously, if you're from Arduino, you're going to be using, you know, you want to use these kind of headers. But this is, I suppose, largely about trying to bring people from other areas like non-parallax, you know, so if you've got PMODs or if you've got Arduino shields, then it's kind of I guess a gateway to getting up and running quickly and exploring the P2 and with MicroPython, of course, that's also going to be increasingly familiar across different platforms. So that, you know, you'll have people who are familiar with MicroPython on a microbit or some other device, and you know, they're going to have a ball running it with the P2 where you can actually see everything on the REPL screen. Like if you just plug in a monitor, you're right there working with the work that Ozprop's done. So I think it's going to be hopefully, well, it should be a joyous experience, you know, using MicroPython and using plug-in boards with the P2. You know, that's what we're aiming to create, and, you know, to get people from these other ecosystems more across to the P2. Yeah, sorry, any questions, or are we?
Yeah, I actually like that you were doing that cascade thing with the serial ports, because none of the other boards currently provide that. It's a good idea.
Yeah, and it happens, like, you know, you overflow the number of pins available to you on a P1. I know we don't think we're going to do that on the P2, but, you know, some of those upper pins are already kind of spoken for if you want to use something like HyperRAM. And I can just see, like, it's not that far away. And this board is compact enough that, you know, even if you add 2 of these side by side, so it's 2.7 inches wide, you add 2 of them, you're at 5 inches wide. That's not super large, you know, it's the size of an old 5-inch floppy disk. It's probably how everyone can relate to in this group.
Or similar to your phone.
Yeah, similar to the length of your phone. So it's actually a pretty compact area. Hey, you know what we could do, Michael, is probably, if you make that a flexible connection between the two, then you can make a foldable microbus development system, you know, like these new Samsung phones, foldable. But yeah, I think it's a good way of making use and breaking out, you know, from the P2, either with the Edge or with these dip options.
Hey, Lachlan.
Yeah.
Have you gotten the pin out yet for the P2 Edge?
No, I was going to ask, like, when as soon as that's available, just let us know. And because I started trying to guess things, and I thought, oh, hang on, there's no slot in it, so I wasn't 100% sure whether it's like a PCIe connector or whether it's some other system. But But I figured no matter what it is, I know roughly it's going to be that you know, I think this is like 56 by 10 millimeters roughly. And so it'll fit in the middle there regardless. Yeah.
Yeah, we were going over that today. I was with Von Sarvash, and he gave me the dimensions, but I think you have the same part number. But anyway, the pinout is on 50 thousandths, where it's kind of zigzagging down on either side. So the rows are, how does it work? They're staggered. Anyway, it's too bad they didn't make a part that respects 100 mil grid, because then everybody could just make a simple board for it.
Yeah, I keep coming back. 100 mil grid is a wonderful invention, and yeah, because a lot of these, well, we look at these like compact, you know, you can get 50 mil grid connectors and things, but when you look at the total footprint, like by the time you're like, I think I worked out they're about 15% better on density. They're not like twice or 4 times as good on density when you're trying to get things connected. You know, you still have to allow space. And so, you know, I think 0.1's got a lot of life in it yet. And of course, as we all get older, it's a whole lot easier to solder, you know, the larger 0.1 inch than it is even the 50 mil stuff. So it's not going away anytime soon.
Yeah, we went around and around today because someone had, was it Jim Hine who came up with this idea for this P2 quip? And we were looking at that, and it's like this route that it's like this circle that we've gone around several times of trying to like bust out of all the confines of the standard connector systems. And we just realized in the end, it's like the edge connector is a little non-standard, but the connector for it's cheap. It does require some kind of custom board to plug into. But then if you look at like putting a lot of single inline pin strips with the female headers, it doubles or triples the cost.
Yeah.
And unless maybe you can find the parts on Amazon. We noticed there you can get a 1x40 header for like 20 cents,
yeah,
which is way cheaper than any distributor. You know, it's coming directly from China.
Yeah. Yeah, it's we find it too. Like you know, it's a constant. Like it's familiar. It's useful. It's you know, you can stack things easily with it. And you can go down to any electronic shop in a hurry and buy, you know, a way out of some kind of problem. And so I'm quite a fan of the 0.1 inch system. But what's really nice is just when you have something which is nice and integrated, like what the Edge is or whatever, you know, just something which has got all the surface mount switch mount stuff looked after for you, and then the rest of it, you know, 0.1. So with this, some of these designs are actually dual footprinting. This is a surface mount flash here, but I don't know if you remember, Chip, they used to be able to get dip version of the flash chips, and then they all disappeared from the market. This was back in 2013, 2014. We used to program P2 hot with plug-in flash chips, and the advantage of that is, you know, your version control. You know, you knew where you were, and if you needed to go up a version or down a version, you could just physically replace the dip 8 chip. And those disappeared from the market, but you know what? They're back, and so Giga Device and Winbond have both brought back dip 8 versions of the flash chips, you know, in that W25Q series, and they're not, I don't think, in the size or density, but they seem to be increasing. Each time I look, there seems to be 1 or 2 more models. There's not a lot there, but they do exist. And for a few years there, we were actually just soldering. We had one of those breakout boards adapters, which we were soldering Ozprop will tell you, we were soldering the flash chip onto that breakout board so we could still use a pluggable flash chip with the systems out in the field. And yeah, so that's, you know, that's a combination. And of course, with the crystal, it's the same deal. You know, sometimes it's useful just to be able to change the crystal. It's not that hard to remove a surface mount device. So pulling a surface mounted crystal off and then manually soldering it at like a 25 meg one if you wanted to change the crystal frequency or something, you know, it's not a big deal. On this though, the regulator side will probably all go all surface mount, you know, something like an MPS 3632 or something similar to that, you know, for doing the switch mode voltages. I don't think we'll do well, I shouldn't say that. Maybe we will. Maybe we'll put a a TO220 style header, because you can get so many. These are all 5 or 6 different brands of 7.4 switch mode, 7405 equivalent switch mode regulators. They're from 5, 6 different vendors, Murata and CUI and others, and Recom and XP Power, and there's all these different brands of those things. So maybe it is worth just putting 3 pins in there for the switch mode conversion. The only thing is I'm not sure if many of them go down to 1.8 volts, but we'll find out.
Yeah.
Yeah. Now, where did we get to? Okay, so I should ask any more questions on the on that 3x3 inch breakout board before we move on. No, okay. So one thing we're going to be doing, we're going to develop some of our own microbus breakout boards. This one is the MicroPython board up close, so you can see there the servo header. There's another one on the other side of this the keyboard socket, and the encoder with all its inputs and outputs and encoding, etc. So we have not far into it, but that's the the basic layout of that board. They actually make a triple, there's actually an RGB shaft version of this if you're really into the extra colors. I think we're going to save the RGB version for some kind of Eurorack or audio module, because that seems to be where these things are used most, because we don't have actually enough pins to drive the third color. Yeah, on that module, so 12 pins here. 12 I/O pins, which that standard that Von Zarvis and Johnny Mack are using. This enables us to also do HyperRAM. So we're going to try a little HyperRAM module in there, because at the moment the HyperRAM is kind of transitioning from version 1 to version 2. And there seems to have been some issues maybe with version 1, because I know there's been a few no return kind of things on DigiKey, etc. And so maybe there was some kind of fault or errata or something. I don't know what exactly happened, but so there's just a few of the version 2 devices. There's a lot more in 1.8 volt compatibility versus the 3 volt compatibility at this point in time. You've also got new manufacturers popping up like WinBond, and so there's actually quite a few options. And of course, on top of that, so you've got different voltages, you've got different speed grades. So, some of them, the version 2s do 166 meg, some of them do 200 meg. You've got different clocking methodologies, like Evan and Roger have been using, and Yanamani and Ozprop, have also had HyperRAM stuff up and running previously, and Richard, RJSM as well, and possibly Rayman, I think, in the past. So all these, you've got all these different kind of control strategies, you've got different devices, and then you've got all these variables about what might actually enable the HyperRAM to work. So things like process, your process, you've got your voltage, you've got your temperature. And so there's a big array of all these different options. But if you have one of those modules in a microbus format, then we can easily just swap it in and out. You're not desoldering it from a board or something. And also there seems to be a bit of a need to tune the clock, and so you can have like a serpentine kind of clock signal, which you just short out the tap to set the length on the clocking signal and control the delay. And of course you can put, like a local 1.8 volt regulator if you need that for I/O. So I think this is, something we'll probably have a go at, just a little HyperRAM plug-in board. Again, that's something which is completely missing from the microelectronica range, despite the hundreds and hundreds of boards. And it's partly probably because they don't have the same, they don't have the full 12 unencumbered pins, which we do with the current proposal with the P2. So
Lachlan,
yeah,
can I ask a question?
Yeah.
So that struck me as interesting what you just said, because on the click adapter that we have 12 pins and none are shared. Are you suggesting, or are you telling me that on the microelectronica, on their dev boards, they're sharing lines?
Yeah, they do. They have to, because, you know, they have multiple. So the board I've got here is, so this is one of their latest. I can't actually see my own picture at the moment, but so that's a version 8 board. And this is they have a couple of versions of version 8. This is a PIC thing. So one of the things I'm hoping we should be able to do, this is a 40-pin DIP processor. This is our thing. Now we might do a PIC version of this, which has only got a couple of voltage pins sort of shifted, which can plug in there and access all these. And I was optimistic, you know, this would be an easy shortcut to do for existing, you know, people who are coming from the PIC world who've already got this board or a version 7 or 6 or whatever, which has also got the DIP 40 socket on there. But because this thing's only got, you know, 30 odd IO pins, they have to pin share. And so what you find is like pin 1 and 5, slot 1 and 5 are virtually identical. The SPI bus shared across slots 1 and 2 is like all in parallel. And of course, on each one of these, the I2C and the SPI are also, you know, sort of shared through. So they do all these kind of tricks to compact down the pins that they don't really have there.
Yeah,
It's kind of a compatibility matrix, right? So that
yeah,
when you're putting in slots, you don't end up with conflicting pins.
Some of that comes from how the chips IOs work. Like a lot of those chips, they use the same pins for both SPI and I2C, and you just switch the mode inside the chip with software on the same pins. So that's why they have to share.
Okay.
Yeah, so I started digging into this and looking at the schematic and all that. And I realized actually there's so much sort of reuse and coming from a P2 world where every pin is kind of free and, you know, roughly created equal, you know, to other pins. And it's quite an eye opener to realize how tangled these systems are. They've kind of gone the other way. There's a pro version of this which takes a CPU card, which you can also buy. And it has, I think, over 320 pins on that card. And so they do bring every single individual pin from these sockets down to that Pro card. But they've only recently started going that direction, I think. And they've kind of got the reverse problem. Now you've got a Pro card where you've got, you know, 60 pins or 40 pins or 30 pins or whatever the PIC has. But you still have to choose like how you're going to map that out to the things where you don't have as many pins as you have up here. And so they kind of have a similar problem with the, even though they've sort of smashed it wide open with the CPU cards. When I bought this board, I didn't look at it too closely. I was just assuming that these configuration switches would kind of set up somehow the microbus slots, but they don't really do that. These are for configuring, you know, splicing in your LCD display. This is for splicing in like a USB UART. You know, and these ones down here are like pull up, pull down kind of things. And so it's, I imagine there would be more configurability between how the pins here connected there, but it's not really how they do it. I should say also microelectronica, it's a fairly recent thing to have like this many sockets. I think a lot of their development boards maybe just had 1 or 2 click sockets, you know, for a long period of time. But as this ecosystem grows, obviously it becomes more capable of covering more of the application up there. And so you need less kind of plug-in stuff down here because you can do it all up there. So I think right now, you know, if we get a P2 out there which can have multiple slots, a similar kind of number of slots to these development boards, but you know, go super fast and maybe do things like HyperRAM and video. You know, none of these systems are doing, you don't buy any of these with VGA or HDMI or composite or anything like that. You know, there's all these kind of holes which are in the PIC system and AVRs and whatnot, which, you know, in the P2 it's been possible to do all this stuff easily for, you know, over a decade. So yeah, it's going to be a fun kind of merging of, I think, the different cultures. You know, the people who are used to using these systems and you know, what the P2 will offer using the same hardware, you know, whether it's PMOD or microbus clickboards, you know, so yeah. The other thing is these microbus boards, they're super easy to kind of work and prototype with and build stuff. And so I think, you know, Ken's initiative to get involved with these and you know, it just makes a lot of sense and it preserves an investment cost. You know, obviously you can use it with other systems, and there's so many of them out there. So, you know, I think it's it's going to be a real boon for P2 development, and really looking forward where we can get it to. But the key thing is obviously we've got to catch up with the drivers and make sure that P2's got a similar number of drivers to the other boards out there. A lot of the code is in C and available in the download libraries and things, and I think fairly universal from what I understand. Or increasingly, Microelectronica are releasing stuff which consolidates and makes universal the driving code. So
yeah, I've started porting some of the code. I actually had to go to Git to kind of find the source for the modules. The stuff that they make very easily available is pre-compiled, since they're primarily driving C and things that can use pre-compiled C libraries. But once I found it, it is fairly straightforward C code, and I've started porting over drivers. And I had an exchange with them the other day, because since they are the Microelectronica modules, I'm trying to keep my naming conventions fairly close to what they use. So as you indicated, if somebody comes over from one of their PIC boards to the P2, there's some familiarity there. And but it is, it's spin and it's my styling. So I sent them one of the programs and I said, hey, are you guys okay with how I've given you attribution? Because I have a pin, a little, in the header of the program, there's a pinout for the module to show which pins are being used by the module that's in that file, and an explanation of it. And then I even put a link to the Microelectronica source code to say, hey, this is an adaptation from this code. I sent it to them. They sent me a note back saying, hey, that's great with us. So I said, well, hey, since Parallax is getting involved with the clicks, maybe you guys should build one of those groovy dev boards for the P1 and the P2. So they said, well, we'll have a look at that. I'm not holding my breath, but
that's right. Well, they got. I mean, I realize the same thing, John. I think they're obviously quite capable of building. They've got about 8 different ecosystems, including TI and even the FTDI processor. FT900 or whatever it is. But I suspect we can get something going from the Parallax end or the user end faster. Or in fact, that's kind of where we're heading fairly quickly, a whole lot faster than we can get Microelectronica to get that whole board. But what's interesting is that because they've already made some moves towards like universal kind of supportive stuff, you don't necessarily have to design a new development board, because you could take like the PIC board and just design a CPU card which uses the P2, for instance, and that's literally just a P2 on maybe a 3-inch square board, those CPU cards, and maybe if we do a prototype version of it, I wouldn't be surprised if they could pick up and run with that from their end without having to think so hard about it, because there's a few things. Obviously, we know how to do this from the Propeller end. And I suspect it's probably, they're probably going to look at the Propeller data sheet and think, oh, how are we going to get up to speed with all this? But it's not, they don't necessarily need to get up to speed with the whole thing. You can sort of provide it's all about the culture of how pins are used. And of course, with the P2, you don't have those kind of pin trip ups or tanglements like you have with other micros, where you've got to choose where you put your SPI. Hopefully, maybe sometimes these things are competitive. You just put something out there which seems to do a job which maybe they were intending to do, and you might find that they get onto it faster that way. So I don't think if we do a breakout board which takes the P2 edge and breaks out to 4 microbus, which kind of looks a bit like their uni-clicker kind of things and all the rest of it, then maybe they can see the benefit to that. There will be some things which will probably catch your attention with respect to the ease in which you can put video out of the P2. I know that's not necessarily a big deal for everyone, but from what I can see, it's a tough thing to do with the current Microelectronica click boards. I don't think they've got options there, and in fact, because it's all treated as a separate. You do it through the display, the LCD ports and things like that, and it doesn't have to be done that way. You can just if you want, with MicroPython, we have a 2-screen system. You kind of have the REPL screen, and you kind of have an application screen. In how Brian has developed it and have, you know, some of our past videos show. So we just have 2 VGA monitors hooked up, and you know, one can be displaying a memory map or debug information, the other one might be editing or showing the REPL, and it makes it super easy to get stuff done fast. And you know, that's it's a real boon for development, and I think hopefully some of this P2, this stuff we're doing innately with the P2 and doing already, and you know, we'll kind of catch on. I also think with one of the things I hope with this Proto 2 kind of board thing we've got here is just hopefully we can do some quick demos where you've got just, you know, this MicroPython board which does quite a lot of, or can do some basic UI, and also you've got a keyboard and keyboard and monitor there at that end of the board. Hopefully we can do some really simple demos where we say just connect that with the grid eye, like the thermal camera at the other end, or whatever sensor you like, whatever microbus sensor or clipboard at the other end, and you can basically just use the UI of this MicroPython sampler to maybe, you know, change whatever it is, volume thresholds, and see the results instantly, like display the data and the VGA. You can use MicroPython to tie all this together fairly quickly, or obviously Spin or PASM, you know, and it's going to be easy to do this stuff with the P2. Traditionally, it's sort of hard, I think, with other systems. You know, it just involves a lot more thought, but we can make something pretty slick and standardizable. I was thinking you could almost run a pairing button in the middle of these 2 kind of things. When you press the pair thing, it kind of connects the 2 modules that you've got pressed at the same time or something. Sorry, that's more for you know, this one here. If you had some kind of deal where, you know, when you press one button on corresponding to this module and one over here, if this is a VGA one and that's a sensor, then it shows that information. You know, these kind of ideas would not be hard to do with the P2, and would really showcase something which is, as I said, sort of more difficult or unthought of with other systems because of the layers involved. Yeah, sorry, we've gone off on a tangent, John, but yeah. Is anyone still awake? I can't see the pictures, so sorry, I'm just...
Oh, we are listening, listening.
Yep. There's a close-up of the DIP 40 on the microelectronica board, and that's our, you know, we've got a range of modules here which we're starting to play with, but mostly around things like light ranges, you know, light distance measuring kind of stuff. There's also an analog devices, where is it? There's an analog devices board, which this one here, it's like quite an expensive analog devices chip, and it does sort of generic 4-channel I/O breakout. And what's going to be fascinating is to run the P2's I/O up against this, because I think it's going to be pretty similar. And you know, this is a sort of a highly specialized board from a highly specialized company. And so what we'll be able to do is do a comparison of, you know, take the same signal, put it in through here, and also directly into a P2 pin, and see how it compares, and see how much of the kind of niche analog space the P2 can actually tackle. On the forum, I've put up some ISO drawings of these modules. So this is the dual 80 module. It's got the pin numbering up the top there. I need to do more work on this. Obviously, it makes it hard to see, you know, that there is a flash chip, etc. But I'll do some work on it, trying to make it a bit more intuitive. I'll do the same thing for the DIP 40 version, which basically, you know, deletes these outer pins and inserts a layer. The DIP 40 just has these pins corresponding to beneath these labels here, and they're just, it's like a parallel version of the header to give the correct 600mm spacing. That's the overhead view of the same thing, which, yeah, I'll put the flash chip in the crystals and bring that up to speed. I'll post all that in the forums over time. I wasn't really ready to release any of this stuff, so this is all just sort of thrown together, but you know, hopefully it gives a pretty good idea of what we're doing and where we're trying to get to, and so people can decide whether it's of any use for what they're doing. All right, I think that's about it. That's taken a while, so yeah.
Super.
Very nice, very nice. I like it.
Yeah. Yeah. So, any other questions or anything else that Ken, did you and Chip wanted to talk about something or?
You mentioned something else to me in an email that was pretty darn exciting.
Yeah. Yeah, I have an agenda here of stuff and I just skipped straight past it. But so MicroPython news. Look, Roger has been playing with the current version of MicroPython, so that's version 1.13, and he's got a preliminary version going. I think I got a message from Brian last night to say, Brian, you'd got that successfully. Seems to check out okay so far.
Yeah, I was working on that late last night, hence why I'm a bit weary this morning. But yeah, it's all looking good. 1.13's hooked into all my stuff, and I was running tests last night, and I'll continue doing that today. But it's all looking good. So, so the latest MicroPython's alive and kicking.
That's awesome. Yeah, so we know there will be another version sometime in November. Could be late November. We're not entirely sure, but the thing that bodes well with this 1.13 had a heap of changes in the changelog. It's like 400 changes or something to that base, and so you know, to even get it sort of running at this stage is good and bodes well for just doing a quick compile of 1.14 when it does come out in November, when the P2's ready for release. Other MicroPython news, they're doing some work in the PWM improvements. Mostly I think that's going to affect other platforms, not so much the P2, where we'd probably do PWM via the smart pins. The Google Season of Docs are sponsoring a Canadian writer to help with the documentation of MicroPython and getting that, making it more professional. There's a lot of stuff happening in the MicroPython world. There is also now, if you're feeling rich, there's a sponsorship page on GitHub for MicroPython. We've started sending some money there to assist with the sponsorship, you know, because we know that it's a fairly small committed team who are doing the bulk of the work, and just, you know, helps to support them a little bit. We also, this MicroPython sampler, you know, if we get proceeds from that, then that will go towards MicroPython development. So we'll release that little clipboard and some matching hardware to enable people from outside of Parallax mainly to experience.
Okay, stop right there. Now you're being very humble. You're saying that we can support you to help get the MicroPython effort done, and you'll apply the funds to the boards?
No, well, we'll just have like some mechanism where we can forward the funds from. For a while here, I mean, obviously we've been sinking some money into MicroPython development, but at the same time, it'd be good to pass to find a way to couple that up to what is largely a voluntary effort out there at the moment with the coding. That's starting to shift. They're going for sponsorship with GitHub. And you know, the companies can, and there are quite a few companies actually developing products with MicroPython. We're not the only one. They are starting to you know, support those efforts and recognise that it's you know, for all the gravitas that MicroPython seems to have out there at the moment, it's not a big team who are you know, doing the bulk of the development work. So you know, it's kind of at that it's not a critical stage, but it's probably important to make sure it grows how it can, and yeah.
You get us a link for that?
Yep.
We haven't done much other than pressure you to keep, you and OzProp Dev to keep going. So we should be contributing somewhere.
It's a new, it's the link into chat. I had a fairly humble goal of reaching, I think, $1,000 a month or something to, you know, just pay. That sort of shows the level they're currently at. You know, and they should be obviously hoping they would think bigger. But you know, they got what is it there? They got 30 sponsors, and so you know, it's a lot of them are familiar, but of course there's a lot of people around the world using MicroPython. You've got companies like Lego now using it, and you know, the microbit, of course, and you know, Ken's a big fan of the Mu editor, which is commonly used with MicroPython. So yeah, it's going, and it'll be, you know, I just hope that these guys enjoy where it takes them, because you know, they're a good bunch of people, and they've been, I think it's 7 years old now, MicroPython, so it's not like it's been, it's not a sudden development by a big company. It's there was as Brian will remember, it was one guy's dare. I think it was Damien's friend who dared him to do something in this area, wasn't it, Brian? The story, the backstory. Yeah,
that's right. It was a dare, and there might have been beers involved as well, I think, when the dare happened. But yeah.
So Damien's a kind of a scientist by background, and you know, probably doing some data manipulation and in between, you know, writing papers and things back when it was created anyway. So yeah, it's a kind of it's a good thing, and it's getting better. There's also a little bit of news. There is also they're doing a little bit of work. Damien actually created this command line. So doing more with the serial link that connects to the REPL, normally just connects to the REPL. And what he's been doing, he's got a program which is currently called MPR. He's not necessarily set on the name of it, but this MPR utility enables you to actually mount your PC file system from the MicroPython end. And so that sort of goes some way towards like how CircuitPython do that flash sharing kind of thing. And so it's a utility, but it looks like it's going to evolve, and coupled with, or if you look at it, there's some similarities with what Chip's been doing with his debug portion of Peanut, those debug screens, you know, using the serial link not just for debugging, but for more information, or for you know, some kind of file or data access. You know, it's it kind of makes some kind of sense to just make it easier to span those two domains. And so MPR, there's sort of some trial code available and things, and I know that you know, some of the guys likely have been testing that on Windows and things like that. So it'll be something to watch, and at some stage it might be highly relevant to bring some of that into the P2, or even vice versa, to take some of what Chip's been doing with the debug code and sort of add it in, bake it into the mix. So yeah.
I added Parallax as a monthly corporate sponsor.
Oh, good on you, Ken. Yeah, that's great. No, it's I think, you know, as I said, it's still in a kind of fledgling phase in a way, and so I think that's you know, we feel it's the right thing to do. So pleased to hear you do too. Yeah.
Well, I value it highly because of our work with the microbit and education, and this is one way to get to other platforms, which, as we know, is a little bit of a struggle for us internally.
Yeah, it's and it's, the P2 is such a good match for MicroPython as well. You know, going forward, you know, I know it's really going to shine in that world, which is so used to kind of just a fairly bland serial REPL kind of linked to a Unix-based system. So, you know, it'll what we'll provide will be something a bit different to the usual MicroPython experience. And you know, having watched Ozprop over what, year and a half, you know, and what he's done with it, it's super nice and super inspiring to use. So yeah.
Is that a Patreon sponsor?
It's an ongoing. It's a PayPal.
Okay.
Yeah, it's a new feature of GitHub where you can sponsor devs, and they have tiers just like Patreon does. It's just done differently. It's handled differently than Patreon does.
Okay, I just got it up. So yeah, I see it now. Okay, cool.
So Lachlan, you still anticipate something then November-ish? And Brian?
Yeah.
Sorry. Yes.
Yeah, for sure.
Okay.
Yeah, we thought we were going to see how hard it was to compile as to whether we use the current or the new version, but it looks like we'll run with the new version, which will be up to date.
Great.
Yep.
I have a special place for it.
When do you foresee all your boards that you described earlier in your talk being available for us to buy?
We're flat out with production at the moment with some jobs which have been consuming us like majorly for about 4 or 5 months. I have, many trays of P2 chips sitting there, which I never thought after 10 years of waiting, I would still not have got to after, the few months that they've been sitting there. So that's, a modern tragedy, but we will get to them as soon as we can. I think realistically, it's going to be of the order of 3 weeks. The designs I can actually close enough to actually ship off before. So while we're still super busy, obviously there's a delay of a week or so while the boards get turned around and come back. And so hopefully I'll be able to send those off maybe in a week or a week and a half. And then by the time we're free of our production work, we'll have those systems running. But I should say, we did a lot of development work on this much smaller kind of thing. You can see the origins of it there. You can see there's a DIP 40 kind of thing on the back, a soldering connector. That's kind of a fairly expensive, when I say expensive, it's probably $6 or something, Milmax brand connector. It is kind of nice in that you can solder it to break it out. So a lot of the concepts and things were, been developed on that board, and we've just sort of taken them across to the 0.1 inch one, which we think will be useful to more people, and sort of it's less aesthetically, this one's super symmetric and all that kind of thing, has hyperram down on the board there. But, the 0.1 inch thing, you can't beat it for the convenience and the fact that you can just buy these stacked headers, they're used for, from everything from, Raspberry Pis and I think BeagleBone, we can use them, some 3-pin or 6-pin short or whatever, but they're available. They've been used for years on PC 104, and that system is still going strong. They're still manufacturing PC 104 boards, and they got a high quality square pins. They're not these kind of cheap, thin rectangular kind of things, which make variable kind of contact. So, yeah, I just, it's kind of complementary with what Ken's doing with the Edge and that plug-in connector. We've also got some ideas about how that can be used to great effect for something which, be quite different to what's out there in the marketplace. So I think there's definitely room for both kind of approaches. And, you can't top the price per pin on those Edge connectors that are actually used in, computer systems. You just can't beat the price per pin.
Anyway,
awesome.
that was a lot sooner than I was expecting. I was figuring it'd probably be more like December or January. If you're talking about a few weeks, then that's awesome.
No. It's that routing, the board routing is being ripped up or just manipulated a couple of times. But I'm not looking to put a whole lot on that board at this stage. What will be interesting is that whole top surface will be kind of free, but I want to just leave it free while we work out what the right thing to put on there is. And, that may be to show off the P2, something like the Goetzel stuff, but it kind of depends on, it depends also on what Parallax, how they want to show off the Goetzel thing and whether, that wants to be a special thing that only the, you buy the evaluation board and those kits. Or whether you want to start integrating into product to show how other people might integrate it into products and have this as an example. So we'll have a discussion with Parallax at some point about that and just see what, what could be done with that thing. It's not really like the Flipboard. The Flipboard's super nice and it's got those nice big labels on the top layer, and you could do that. But with these, both the DIP 40 and the Dual 80, you've got headers in the way which obscure the view of the top surface, and so I kind of think we'll come up with something, but I kind of like the idea maybe of, some kind of Goetzel thumb joysticky kind of thing on the middle of the, so if you don't have a microbus, if you don't have the microbus connector there, then you could use the microbus pins as Goetzel receivers, those 12 pins we're talking about, those IO pins, in a Goetzel mode to like resolve almost like a air joystick kind of thing. You stick your fingers in and you can have really super accurate control. something along those lines. You know, we'll figure out what we can do. Plenty of options, and you know, rather than try and put too much on the board, just keep it to you know, the flash and the regulator and the crystal, and then the rest of it is just I/O pins, and I think that makes it like an understandable and usable system, and it also speeds up the you know, just getting it out there. We've got a company here in Melbourne who manufacture. We've been dealing with for what, 30 plus years, maybe heading towards 40 years, who've done circuit boards and assembly for us. You know, so they're all revved up. We've got the parts. So these are the, you know, the parts are, these are the reels and things ready to send to them, and we've got the P2 chips as well. So because we're, you know, these are the parts from this board here, they can all be sent off, you know, to precision circuits, and we'll get the we'll get things underway. But it's also not going to happen in under a week. I know that much.
I could provide an update on the 9-inch HDMI display driver board situation, if you guys want to hear about that.
Yes.
Indeed.
Okay. All right, yeah. So as you know, we have that 7-inch HDMI, which we could drive well, and then I retrieved this 9-inch display, and we can drive it, but at too low of a frequency over HDMI. And so you guys asked for VGA, and then Roy plopped in with a solution of some driver boards that were on Alibaba, and this be them. And tomorrow, as you can see, there's everything. There's composite, VGA, and HDMI. Okay, so tomorrow I'll hook this up to the 9-inch display and try it out. What's nice is the display cost is low and the quality of it is high, so we can offer a pretty affordable system to everybody. So there are a couple oddities that came with this thing. I'm not so sure about really what they do. There's a ribbon cable that can plug into the board, which goes to this button and infrared receiver. You guys know what this is for, and then I got this funky remote.
So that driver board does an on-screen configuration menu like a TV. So you can adjust color and whatnot, and that's what those buttons drive. Like one of them is bring up the menu and then go up, go down, select, things like that. And then the IR sensor is to use the IR controller to do the same thing, to drive the menus, as well as turn it on and off and stuff like that.
That's pretty handy then.
Yeah.
So I'll let you guys know tomorrow. I forgot if I ordered 2 of the same boards, but I was ordered 2 of everything from China. I think they're the same. And then I'll get with Chip and get a driver that can really exercise it with VGA, right?
Hey, Ken, I have a question.
Yep.
That VGA connector, was that an input or an output?
It's the female side.
Yeah.
It's an input. It's to drive the display.
Okay, so in other words, we can drive VGA into that and it will output some kind of HDMI to the panel?
It's not HDMI, it's the LVDS, the actual panel connector.
Oh, okay, good. All right.
On the other side of the chip. It takes composite VGA or HDMI and translates them and then displays them on LVDS for the panel.
Wow, well that solves well, that means we can do video with 3 pins. Well, does it do component, Ken? Do you know?
Yeah, it does.
It has composite, not component.
But might there be, I mean, if they're covering all those, might they have covered component also? You see 3 pins anywhere, Ken? For something that's like a ground and 3 signals?
I looked for it, Chip. I'm pretty sure it does not do composite. It has the VGA, which is basically 3 signals plus sync. So that's probably why they didn't add component.
Gotcha.
And Roy,
they do exist.
I'm gonna have to send you shopping for a power cable again. Looks like
I thought it was the same little 3-pin connector on there.
Oh, you're right. It is. Yeah.
And I think it also has a barrel jack.
Yep, that's correct. All of the above. The 2.1 millimeter DC barrel jack as well. That's pretty handy.
And you can get a barrel jack to pins to plug into a board if you need to, like a breadboard or something.
And I hope would we be so lucky this is 5 volts? That's the adapter we're stocking, a 2 amp 5 volt.
I think it is.
It says on the back. Well, no, that's not any current or power. We'll go look at the specs again. Anyway, the only problem with this, like a lot of the stuff from China, is when you order 2, they keep these boards attached, and these are not going to break with our pizza cutter because the connector's in the way.
Oh, they
I think
didn't
you could
separate
just,
them?
I think you can just snap them. I think they're already scored.
I've already tried. This is the kind of stuff that drives our manufacturing staff nuts. Okay, yeah, they snapped. They're okay. May have broke it on the way. I'll find out tomorrow.
Yeah, I've run into the same thing ordering quantities, because I, like you, always get at least 2 of everything I get from China,
Yeah.
just because sometimes one doesn't work. But also they come connected together and you have to snap them apart.
We've used a similar product from like a proper company called Digital View years ago. My memory was those were somewhere between $100 and $200 boards, but I think they had component. And so I'm sure there are, if you look at a company called Digital View, I think they're Taiwanese, they also had like professional kind of LCD driving boards, and they might have the component option Chip was after.
So
Yeah.
if we had this 9-inch display with this multi-input driver board tested for customers for $49, $59, that represents a favorable thing, doesn't it?
Oh yeah,
Yeah.
I would definitely get a couple.
Okay, and it's a lot of this is cast off material from Raspberry Pi efforts in China.
Yeah, well, the reason I knew about that particular board is that I have a 10-inch panel that's 1080p and used one of those boards that I got from Adafruit many years ago, and it was intended for Raspberry Pi, but it had the other inputs, so I was using it with other things, including P1.
Companies like this on Alibaba, I kind of got to test them, order 1, 2, then 20, then 50, see how it goes, because they packed them in envelopes like this, you know, so they were side to side smacked, just kind of mashed in there. So we'll see what they do with 20.
Yeah, when you order a large quantity, are they just going to all be smashed together in a big envelope, or are you going to get a box?
Well, likely they're going to break it up in small packages to get the e-packet rate. Don't get me started.
Oh, yeah. E-packets.
Let me tell you about it.
Well, Michael and I were looking today for connectors, and we first go to the obvious places like DigiKey and Mouser, and everything's expensive. You know, we should look at Amazon. It's something that a lot of people use. I mean, they have those headers for like next to nothing and all those wire packages. That's all that.
Chip, I've actually been buying some less critical inventory, not for production, like RGB LEDs, that breadboard that Lachlan was showing earlier. I found a much better version on Amazon. That again, thanks to e-packet rate, shipping from China, China subsidized, and American subsidized, order value under $600, weight under X pounds, is cheaper than we can buy them from China by a long shot.
Yeah,
but it's still coming from China.
Yeah, they just identified the loopholes and are
they know how to
prosper right now.
Yeah, it's good when you on Amazon you can find the ones that they've shipped to Amazon warehouse in bulk, and you can get them. There's usually slightly more than the ones that come via e-packet from China, but you get them, you know, like next day.
Exactly. And those are essentially the prices we would pay for 1K units. So it's very level now. Things have really leveled out because of the little loops they're aware of. Amazon's winning big. So they'll just keep drop shipping those little packages to Amazon's warehouse.
Yeah, the thing that I've been finding, I've been ordering a bunch of N-scale railroad stuff from eBay and Amazon lately, and the slowest shipping is from Europe. Like I get stuff from America in a few days. I get stuff from Japan in 2 days via DHL.
Mm-hmm.
But like something from Germany and something from I forget Finland or Sweden or something. Anyway, I'm still waiting. It's been like 3 weeks, and they're predicting another couple weeks. Deutsche Post and some of the others. It's weird how much slower it is from Europe than everywhere else.
It's just really, truly maddening too. I mean, we benefit from it, but we pay for it elsewhere.
Sure, yeah.
Stephen Rocco, do you want to share that? You had a question and a really cool picture you sent me of your RGB LED array. And you're on mute.
I wasn't thinking about that, but I guess I could.
Yeah, you're asking about how to get your first question that I didn't answer, how to get from HyperRAM to P2.
No, sorry, I was just trying to show examples. You have prototyping boards for single connector use of the eval board, but not for dual connector. And my example needs more pins than I can get from a single connector. So I was trying to figure out how to build something one-off. I'd have to get 2 of your proto boards and wire them both together if I wanted to do it that way. Let me show you a picture.
That's the example in this with this RGB array then.
Correct.
Yeah.
And
there are 2 different proto boards.
Yes.
There's one which comes in the kit and there's a separate one as well.
Correct. There's both of them are single connector for the eval board.
Mm-hmm.
And I have both. But I'm looking at both going, I wish one of them had 2 connectors, 2 landing pads for non. I'm trying to find, put me on the spot here, Ken.
Yeah, sorry. I'll bring your picture up. I got it.
No, I got it right here.
Okay.
I spent years on the Hewlett Packard Logic Analyzer team, and so I have tools I get to play with that are maybe slightly different from others, but
we're still missing the video.
Yep.
There we go.
There I am. And so basically this is the Hub 75 connector, and it's a 6-bit wide path, streaming bits out clocked, and you gang these panels, serial stream them. And so people are doing walls or full large scale displays with these panels. They're a little bit high power use, but they're fun to play with. Meaning that if I drive this thing full white, I'm 3.6 amps per panel. If you put, 10 panels to a display or 20 panels to a display, that's a bunch of power. But anyway, these things are individually addressable, 3-bit color, but you do PWM to get full 256-bit. I'm sorry, full 24-bit stuff. And so I'm doing the P2 drivers just to make them work. And you set up the chain width for how many panels you have cascaded, and then that's all working. And so this is the panel actually working.
Yeah, Rayman did driver for P1 to drive
yes.
1 or 2 of these. I think he got it up to 4.
Correct. And I started working from his, and what you find is there are 4 different chipsets. And of course, the panels I have the most complicated chipset out there. And they are Chinese data sheets. And so my process is Chinese data sheets, translate to English, redraw, merge the 2 together, and then pin map the IC routing. So now I have schematics, and now I have it running. They run quite well, and it's real stable. And by dropping the refresh rates, actually speeding up the refresh rate, you actually draw less power, which is interesting, but makes sense when you think about it.
So Stephen, you said that's 3-bit. Does that mean 1 bit for red, 1 for green, 1 for blue?
Yes, it is.
Okay.
Yeah, and then you PWM them to get multiple shades of each.
Correct. And so what you have is the top half, the top 16 rows are 3 lines driven, and the bottom 16 rows are 3 lines driven. And basically this needs, I need 2 headers worth of connectors out there, not quite 2 full headers, 3.3 volt to 5 volt level shifters, and then direct connect to an IDC connector on the back of the panel. I could flip it around, but, and then I'm watching signals on the scope there so I can check my timings and everything.
I see.
And so, silly me, I didn't pay attention to 3.5 to 5 volt. And I was retraining myself on logic analyzer use when I see bit timings go bad. And I put it down to 5 volt TTL sensitivity, and sure enough, I was not square. As I was driving it at 3.3 volt sensitivity instead of 5. Then all of a sudden I taught myself that, oh geez, I need shifters in there. But fun. But anyway, that thing's working and it's a full scan rate. I can achieve on a single panel 400 frames per second. If I PWM it, divide it by 8, right? And so you're well over video frame rates. That's a 64-bit shift, serial end-to-end per line, per frame. 8. I don't know, you can figure it out. But anyway, gang them, I've got 4 of these set up so I can gang them together and run the larger panels. This is 32 by 64, and I'll run 64 by 128 just as a demonstrator.
And how fast are you clocking bits into those things?
They will go up to 30 megahertz. Right now, I'm clocking it at 18. And so it would require what, 6 streamers to do it, I think, because there's 6 individual parallel bits. So if I wanted to go faster, the full 30 megahertz.
Yeah, so what you're going to do is when you say you shift out 64 bits, that's 64 3-bit sets?
64 6-bit sets.
Oh, okay.
I'm driving the top 16 and the bottom 16 independently.
Okay.
And so it's 3 bits for the top, 3 bits for the bottom, 64 bits across. And then I have 8 rows within that. And so it's that you send it, you get multiplex. So it's kind of fun to drive.
Yeah.
I'll do a little write-up. When I put it out there on the repo, I'll do a full write-up and what I found out. The way this is clocked, as I said, the more difficult chips, you have to raise the latch during the last 3 bits of the 64 for it to latch. So that was wonderfully entertaining. Other panels don't require, other panels do latching after the row. It all depends on what chipset you have. So just
that'll be a great
fun.
Contribution.
Yeah, just a little fun, something I was playing with.
Okay, Ken, enjoy your fun with a broken dishwasher.
Yeah, parts are here.
Stephen, what kinds of functions do you use on your logic analyzer to work on that?